Let us study chemistry together with CBSE Chemistry Tips and Tricks.
What is the wavelength of light emitted when the electrons in a hydrogen atom undergo transition from an energy level n is equal to 4 to an energy level with n is equal to 2? See here, what is the scenario? Electron is shifting from one shell to another shell, right? From n is equal to 4 to n is equal to 2. Correct, right? Definitely at that time energy will be released out in the form of light, and we are supposed to find the wavelength of that light. In such scenarios, what we have to use? Which equation we have to use? Of course it is Rydberg formula, right? What is that? 1 by lambda is equal to RH, Rydberg constant, into 1 by n1 square minus 1 by n2 square. Correct, right? And here what is n1 and n2? Remember, n1 is n final. In this particular equation, n1 is n final. So what is that? 2. Remember it, okay? That is very important. n2 is n initial, and what is that? 4. And what is Rydberg formula? Sorry, Rydberg value. It is 1.097 into 10 raised to 7. Okay, right? That is in meter. Okay, that is in meter. So if you are using RH as 1.097 into 10 raised to 7 meter inverse, your lambda will be in meter. Or if you are using this value, centimeter inverse, you will be getting lambda in centimeter. That's it. Okay, you can use any of that. Now here anyhow I am using SI unit. Okay, let us see. Substitute. Okay, RH is what? 1.097 into 10 raised to 7 by 1 by 2 square minus 1 by 4 square. On calculating, you will be getting like 1.97 into 10 raised to 7 into 3 by 16. On calculating, you will be getting like 2.06 into 10 raised to 6 meter inverse. Okay, then lambda taking a reciprocal of that, which means 1 by 2.06 into 10 raised to 6. You are almost getting like 4.86 into 10 raised to minus 7 meter. Now if you want to represent this in nanometer, do like this: 486 into 10 raised to minus 9 meter. So it become what? 486. 10 raised to minus 9 means what? Nanometer. Okay, right? Okay, that's it.